All right, physics episode 4, more kinematics continued. All right, what are we going to talk about in this video, this episode? Acceleration, interpreting more graphs, x and y graphs, two dimension vectors, and reason about kinematic quantities in multiple dimensions, whatever that means. More typical test questions. The parabolic graph to the right represents the position of an object as a function of time. Which of the following represents the velocity versus time graph for the object? So, um, in the previous video, we talked about how if you take a position versus time graph and you basically take like the tangent line here, you can find a slope which is equal to the velocity. So it looks here, we have an object that it looks like you can see here, it's moving. It has a positive velocity because it's moving uh, in the positive direction. It's going positive in meters, and then it is slowly slowing down. So it has a positive velocity that is increasing, eventually becomes zero, and then begins moving in the negative direction. Right? So it's basically a velocity that starts off really quick in the positive direction and is slowly decreasing, becomes zero. Right here, the slope is zero, then eventually starts decreasing in the negative direction. So we can say that this is a velocity that is constantly decreasing. So if we wanted to see what would be a appropriate velocity versus time graph, obviously B and D are the only ones where the velocity is moving in the negative direction. But obviously, we can see here during the first 3 seconds, the velocity is still positive. So the velocity, it's still moving in the positive direction. It's just decreasing. So right here, it's zero. Over here, the velocity, it's still positive, but it's just moving towards zero. It's positively decreasing. So obviously, it wouldn't be B because we know the velocity doesn't start at zero. So D would be the only correct answer here. And that's right. So acceleration. What is acceleration? The average acceleration of an object is determined by dividing the change of velocity of the object by the time interval during which the time occurs. So average acceleration, you take basically change in velocity divided by change in time. Cool. Yeah, that makes sense. An instantaneous acceleration is just taking the slope. Because I talked about in the last video how you have like derivatives, like the derivative of the position graph will tell you the velocity, and basically the derivative of the velocity will tell you the acceleration. So that's a formula to write down. A average is equal to VF, which we know is velocity final, minus VI, which means velocity initial, divided by TF minus TI, which we know is equal to delta V divided by delta T. Cool. That's acceleration. So typical test question. The parabolic graph to the right represents the position of an object. Yeah. Which of the following represents the acceleration versus time graph? So going back to this one, we already talked about how it was D. It is a constantly decreasing velocity, right? So it's constantly decreasing. So we already said the velocity is constant. So the acceleration is going to be zero because it's not changing speed. So kind of like for example, if you were to see a position graph and it's moving, if a position graph was just a linear line, you know that it's at a constant velocity. So the velocity would just be a straight line. Kind of like here, if the velocity line is literally just a linear line, we know that it's constant. So acceleration would be zero. So if it's saying which of the following represents the acceleration, yeah, it's constant. So it's a constant acceleration, and the acceleration is in the negative direction. So the only accelerations that are, because in C and D the acceleration is changing, so it's not constant. So A and B would be the only correct choices. But remember, it's accelerating in the negative direction. So A would be the only correct answer here. Yeah, so that's right. Direction of acceleration. When an object is slowing down, its velocity and acceleration point object directions. When an object is speeding up, its velocity and acceleration point in the same direction. So what does that mean? So we said here, like, right, so in this example, where the object's velocity is positive, 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 and then slowly becomes zero. So yeah, when an object is slowing down, its velocity is positive, but it's slowing down, and at that point in time, an acceleration would be negative. So just think about if an object has a positive velocity and it's slowly decreasing in speed, its acceleration would be negative. The acceleration is in the negative direction, so it would be the opposite of that. And then also vice versa, if an object has a negative velocity and then it's slowly decreasing speed and becoming more positive, then obviously um, acceleration will be positive. But when an object is speeding up its velocity, and yeah, so just remember in the last video we kind of explained how speed and velocity are two different things. So just make sure you understand that. You don't want to get tripped up on it. Interpreting graphs. To determine the acceleration from a velocity time graph, you need to look at the blank slash slope. Okay, so to determine the acceleration from a velocity versus time graph, it should be and determine the change in velocity. All right, so remember from the last video, we said, what did I say? So if we wanted to find the total displacement um, if we wanted to find the total displacement of area, right, of position, we would look at the area under the curve under the velocity graph. So if we wanted to just take the integral of that, because remember, not the integral, the derivative. So the derivative of the position graph is the velocity graph. The derivative of the velocity graph is the acceleration. So if the total displacement of if the total displacement is equal to the area under the curve of the velocity graph, then that means that the total change in velocity would be the area under the curve of the acceleration graph. So this second one should be area under the curve. And to determine the acceleration from a velocity graph, remember, you would just look at the slope. Like we said earlier, you do the tangent line thing. So this should be slope, area under the curve. Yeah, so slope, area under the curve. So that's right. So free fall. What is free fall? Free fall. If you drop or throw an object, it will experience a constant acceleration towards the surface of Earth. We represent this constant acceleration by the letter G, and we will call it the acceleration due to gravity. The acceleration due to gravity has a magnitude of 9.8 meters per second squared, and its direction is always downward. We say an object is in free fall whenever the only acceleration it experiences is G. So obviously, on Earth, every different planet has its own G force, right? So I think Earth is like 9.8, the moon is like 1.9, Mars is like 4. It's basically just due to gravity, right? So the bigger the planet, obviously the higher the gravity is. So if you were to say, like, drop an object, right, on Earth, gravity is going to pull it down. On the moon, obviously, if you were to drop something, it would move a lot slower because the moon is smaller, and obviously its gravitational force is a lot less. But on Earth, say if you drop a water bottle, right, say after 1 second of the object being in free fall, it's moving at 9.8 meters per second. So it's for every second that it continues to drop, that's how much it accelerates. So after 1 second, it's at 9.8 meters per second. 2 seconds, its velocity is at 19.6. After 3 seconds, on Earth, it's at 29.4, right? So that's the acceleration due to gravity on Earth. And when something is in free fall, we say that the g force or the acceleration due to gravity, which is a constant, at least for Earth, is the only force acting upon it. So, like for example, let's say I drop this water bottle and I catch it in my hand. For that, say half a second or probably even less than that, where it was just falling, it was in what's called in free fall, right? So free fall equals G force is only thing acting on object. And G equals 9.8 meters per second squared. Chill. A ball is thrown straight up, the velocity vector changes, but the acceleration vector is constant. Yeah, so say for example, if I were to throw this water bottle up in the air, right? It goes up in the air and then it comes back down, right? So when I first throw it up in the air, it has a positive velocity because it's moving upward, but it has a constant acceleration of negative 9.8 meters per second because it's in free fall. So it's kind of like what it's saying. It's like, all right, if you throw an object up in the air, like it has a positive velocity at first. And then eventually, when it hits like the peak, its velocity is zero, and then it falls back down. So the velocity vector goes from positive to negative, but the acceleration is always constant. This is a free fall example, right? Yeah, so you see here, you throw an object up, its velocity is positive, it slowly becomes less positive, and then eventually it hits its peak because the acceleration is constantly negative, and then it begins to fall downward. So this is just more equations. Might have talked about this. Oh, these are almost every quantitative kinematics equation can be answered using graphs. One or more of the following equations. Yeah. So, what was that? Yeah, we already talked about that one. Average acceleration equals change in velocity, and then average velocity equals change in position, and then well, that's another good one. Yeah. So a lot of these shoot, I can show you. A lot of these kinematics problems just really require you to understand the formulas and to understand what's actually asking you for. Because one of the problems might be like, say Ben throws a ball like up in the air at how many meters per second after how many seconds like does it take for it to hit the ground, right? So it's basically just understanding these formulas and understand what they're asking for. And you literally just need to know how to plug it into your calculator and get the right question and get the right answer. So that's another good formula there. We said velocity average is equal to velocity final plus velocity initial divided by 2. And all these formulas are like on an equation sheet. Like if you're doing a class, a professor should give you. So yeah, you see here G 9.8, 1 inch, 1 feet, 1 meter. Fire. Kinematic equations all assume constant acceleration. There's nothing new here. All the information. Yeah. So these are just problems to help you solve kinematic equations. So this is assuming constant acceleration. So if the acceleration is changing, these formulas don't matter. But like say for example, if I asked you, you throw a ball up in the air at an initial velocity um, of how many meters per second, you can use this formula and you can put 9.8 in as the acceleration to find out, you know, like when it hits the ground or whatever. So this is velocity final equals velocity initiative plus acceleration multiplied by time. And all of this is just in the x plane, not the y plane. but we haven't gotten to 2D graphs yet. Just talking about X, so does it get more into that later? Oh yeah, adding 2D vectors is the next thing. But I'm gonna write these formulas down. I'm gonna just say assume constant acceleration formula. So this is v final equals velocity initial plus acceleration multiplied by change in time, and this is velocity final squared is equal to velocity initial squared plus 2 multiplied by acceleration multiplied by displacement. And then this bottom one here is displacement final equals displacement initial plus initial velocity multiplied by change in time plus 1/2 acceleration multiplied by change in time squared. Adding 2D vectors. Imagine that a person walks 61 degrees north of west for 8.5 meters and then turns and walks 12 degrees north. Yeah, what is the total? So this is just basically using sine and cosine, right? So you're trying to find the total x and y displacement, but they're at angles. And you're going to have to do this using trigonometry. So the best way to that I've learned to do this, because I messed this up. I literally messed this up on a practice test question I did. So I had to learn this the hard way. So when they say north of west, you need to um, understand what they're asking for. So, for example, let me write this out because I messed up the angle. So, 61 degrees north of west means 61 degrees here. So, say for example, but if it said 61 degrees west of north, you would start at the if it was west of north, you would start here on the y-axis and go 61 degrees. But if it's saying north of west, you start over here on the x-axis and you go 61 degrees. Because I literally messed it up. I was asked to calculate something north of west, and I accidentally took the angle from this place here. I did the math right, but I messed up the angle, so my answer was wrong. So just as a general rule of thumb, make sure you understand this. I'm going to even write this out on a table. So, um, so if it says north, whatever it starts with, what's the best way I could say this? Because if it said start south of west, you would come this way. But if it says starts, all right. So if it says start north or south, you're going to go from the x axis. So if it said start from north, you're going to go to the x axis, and it said of west. I'm just making sure I have these angles right. I'm writing down. So it says north of west. You're going to start x axis on the west side and then count upward from that, right? Because this is um, Yeah, that's confusing because this is supposed to be 90 degrees here, but like this does not look like a 61 degrees. So I don't understand how this is 61 degrees. That's why I'm confused because you can obviously tell like this is wider. This part right here is wider than this part right here. So why would this be the 61 degrees right here? That doesn't make sense. This should be like the 29-degree angle, right? It doesn't make sense, bro. It really doesn't. Is it saying hmm well, because if it was 45 degree would be like this, right? I'm gonna ask ChatGPT. I'm like, there's no way this is a 61-degree angle, dog. Because this is a nine. This entire thing would be like 90 degrees. So there's no way this is like 61 degrees. So we're gonna ask ChatGPT because I'm tripping for real. Well, now I'm confused because this isn't drawn to scale. All right. Well, I literally might get an honor core violation for literally recording these PowerPoint presentations, but I legit don't care. You guys are looking from literally this slide, and I'm not insane. So if I get this wrong on an exam question, this is saying that this is 61 degrees north of west, right? So if this is 61 degrees, that means that this over here is 29 degrees, right? Because this is 90 degrees, right? But oh, I'm dumb. I'm dumb. I'm dumb. The 61 degrees is from this to the pink thing, not the blue thing. Stupid. All right, bro. All right. All right. All right. All right. So maybe I need to read the question. Yeah. So imagine that a person walks 61 degrees north of west. So they walk this distance, they walk this, and then turns and walks 2.8. So they turn around. Oh, wait, no. Yeah, this is R1. That's why I'm so confused because it's like this should be 61 degrees, but they're saying this is 61. All right. So, okay, that's why I'm extremely confused because this should be this from this it's looking like it's saying this is 61 degrees, but this would be west of north, right? Because this would make more sense if this is north of west. So, yeah, this chart is really messing me up, man. We're gonna do the graph and we're gonna see if this makes sense. So, because obviously this is the bigger angle, so this would be 61 and this would be like 29, which is why I'm tripping, dog. But all right. So they turn and walk 2.8, because they walk R1, and then this is a 12-degree angle here in and of itself, and they walk 2.8. So this is the total displacement. So we're trying to calculate this purple vector here. So this here I'm assuming is the 61 degrees. I don't know why they put it right here. I guess to make it look better, but it's extremely confusing. So whoever wrote that needs to get their shit together, bro, because it's pissing me off. So you have north, west, east, and south. So north of west means you literally start north here and then you go west. So if it said west of north, you start west and you go north. So if this is 61 degrees north of west, literally the exact same angle would be 29 degrees west of north. We can even ask ChatGPT, is 61 degrees north of west the exact same angle as 29 degrees west of north? And if so, could you create a drawing of it? Because I'm confused. ChatGPT image feature comes in clutch, bro. Yes, they're exactly the same direction. Your confusion is totally valid. Think of north and west as forming a 90-degree corner. All right, so I'm confused because this is saying this is 29 degrees and ChatGPT is saying this is west of north, and that's wrong. So we're going to take a picture of this and we're going to say, so this should be, if my intuition is right, this should be 25 degrees north of west. Because I'm confused, dog. We're going to figure this out. So this picture right here should be 25 degrees north of west. "25 degrees west of north." West of, okay, so all right. Um, so west of north. If this is north of west of north, then 61 degrees north of west would be this angle, which doesn't make sense if you look at the picture. All right. So could you generate a graph that shows an angle of 61 degrees north of west? Generate a picture of 61 degrees north of west on a graph. What? But that locks in my intuition, and ChatGPT just told me it was wrong. All right, so we're gonna Google. We're gonna go even further. North of west angle. North of west. All right. Yeah. So this is saying that this is 50 degrees west of north. So if that's 50 degrees west of north, then 61 degrees north of west would be this angle, which, all right, we're just going to assume that it's not drawn to scale because my intuition is like really bugging me right now, and it doesn't make sense at all. So I'm just going to assume that this graph isn't right, and we're going to do the math pretending that this is 61 degrees north of west, and then if I do the math correctly, we'll confirm our actual angles because Google isn't helping. Well, Google kind of helped. ChatGPT didn't really help explain it. And then obviously, whoever made this PowerPoint is incompetent. So let's figure this out. So we have an angle which is 61 degrees here north of west. So if north is first, if north or south is first, you start on the x-axis. If west or east is first, you start on the y-axis and you go towards that direction. So maybe if I can even create a picture here, north of west, south of west, north of east, and then south of east. And that's what you would measure from. And then east of north, you would go out that way. And then I'm telling you, bro, this is like one of those things that you wouldn't think are like important, but it'll mess you up. West of south. Okay. So chill. So I got a table written out. So remember trigonometry, right? So we want to calculate this was so lecture 5. All right. So we want to calculate the displacement and the angle of this vector here, right? So first we need to calculate whatever this x displacement is and whatever y displacement is. And then using a squared plus b squared equals c squared Pythagorean theorem, we can basically solve the length of this. But in order to do that, to solve these lengths, we need to figure out the length of this and the length of this. And then to solve for the y length, what do we need? Because we can add these, we can create the triangles here, and we can find the length of this side here. And then once we have that, we can find the distance of that, I guess. I don't know. This is confusing, but we'll figure it out. So, cool. So we have a little graph here, and then we have 61 degrees north of west. So we have a little 61-degree angle, and then this goes for 8.5 meter. Cool. So this is 61 degrees here. So if we want to solve for the x distance, so this distance right here, we would do 8.5 cosine of 61, and that is 4.12. And if we wanted to solve for the y distance, it will be 8.5 of sine of 61, which is 7.3. And obviously, since this is allegedly a 61-degree angle, it's going to be a bit wider, which means that the y would be longer than the x. And we can do Pythagorean theorem to confirm that. So 4.12 squared plus 7.3 squared equals 71. And then you take the cube root of 71, and that should give us 8.5, which it does. So we know that this distance down here, by taking 8.5 cosine of 61, so 8.5 cosine of 61 is equal to 4.12, and 8.5 sine of 61 is equal to 7.43. All right, so we've already kind of solved that. So we know that this is 4.12 and this is 7.43. All right, chill. And now it looks like we have another triangle that's asking us to solve for. So we have a 12-degree angle from right here. So we need to solve for another triangle here. So we need to find the x and y displacement here. And then once we have the total x and y displacement of both of the movements, we can calculate whatever this angle is, and then we can use Pythagorean theorem to find it, and then do what's right tangent to find the angle, I believe. So, okay, cool. Chill. So, all right. So, first of all, if we know that this is a 12-degree angle, then that means if we wanted to make a right triangle here, we know that this would be a 78-degree angle, right? To make a right triangle, it will be a 78-degree angle. So we know that we have another triangle and it is 78 degrees here. And we know that this is 2.8. So to find the x displacement of this triangle, so to find this distance here, we would do 2.8 of cosine of 78. Well, that doesn't make sense. Yeah, because if this is 12 degrees, that angle is going to be really small. So we're basically trying to calculate the length of an entire new triangle. So we know that this is 2.8 and that this angle is 78. So if this angle is 78, it's going to be huge. So we know that the x distance is going to be really large and the y distance is going to be relatively small. So, yeah, so the x distance should be that, which is weird because I put in 2.8 of cosine 0.78 and it gave me 0.58. And I put in 2.8 sine of 78, which is like 2.74, which I know that that's the correct answer, but I'm just trying to understand like why is it interchanged? Oh, that's because basically this triangle here is the same thing, right? And you're just flipping it. That's why it doesn't make sense. But yeah, so if we want to solve the distance here, the x displacement here, we just do 2.8 of cosine of 12, which is 2.73. So we know that this displacement here is 2.74 meters. And we know that the y displacement is like 0.58, 0.58 meters. So to find the total displacement, we know that we already said that he went 4.128 meters in the x direction on his initial trip, and on his trip back, he went 2.74 meters in the x direction on his way back. So his total displacement in the x direction should be 1.38 meters. And his total displacement in the y direction, which first he went 7.43 and then he went an additional 0.58, that would equal 8.01 meters. So now we have a triangle, and we know that this x displacement is 1.38, and this right here is 8.03. So it's asking us to solve this. So we can literally make another triangle, and we already know that the y displacement is 8.01, and x displacement is 1.38. So we can do 1.38 squared plus 8.01 squared, which equals 66. And then the cube root of 66 is 8.13. So we know that the displacement of this is we know the length of this is 8.13. Now it's asking us, no, sorry, bro, I'm really tired. It's like 5 a.m. and I've been up all night. But yeah, so we know the displacement of this, the distance of this is 8.13. Okay. So now we got to find the angle. So if you, what is it? So tangent. What is tangent solve angle? Yeah, so tangent is opposite over adjacent, right? So say for example, if this is A, your opposite is the opposite of A, and then B is whatever is not the right angle. So in this example, if we wanted to just flat out solve for this angle, we want to find this angle right here. We would do, what is it? We would do tangent of opposite, which in this case would be this, which we know is 1.38 divided by opposite, which would be 8.01. Is it tangent or inverse tangent? That don't look right. So inverse tangent of 1.38 divided by 8.01. Yeah, is 9.78. So yeah, we already know that. So this angle should be like 10, or this angle should be 9.77 because I did inverse tangent of 1.38 divided by 8.01. So what is the total displacement? The total displacement should be 8.13 meters at an angle of 9.8 degrees. And remember, this is 9.8 degrees west of north, is what it should be. 9.8 degrees west of north. Is what it should be, dog. Did you give me the correct answer? All right. So we'll check the correct answer in just a second, but we already know that plus and negative y direction. This is basically just going through the steps that I was saying. Uh huh. Yeah, so I got it right. 8, 1.4. Yeah, so the angle, like I said, would be inverse tangent of x divided by y. Yeah, so I was right. So yeah. So the total displacement is I said 8.1 meters, 9.8 degrees west of north, which is right. Which is 9.9, but whatever. It's just a rounding error. It's the same thing. I got it right. I won. LOL. Yeah, so what is so 8.1 degrees west of north. I got that right. That's cool. Cool. Key idea. The motion of an object in the x direction is completely independent of its motion in the y direction. That's true. The kinematics relationship that we've learned can be applied independently to the x and y components of motion. X and y components of vectors are combined to find the total magnitude of a vector using the Pythagorean theorem. And then Pythagorean theorem, just remember it is x squared plus b squared equals c squared. And then we said, what was it? So inverse tangent. So inverse tangent of opposite divided by adjacent is equal to your angle that you're looking for. I got the correct answer. It took me forever to freaking do it. So I just need to train more before I take this test. All right. So starting from rest, a bus driver is driving away from the bus stop and accelerating at a constant rate. The x and y components of the acceleration. What is the magnitude of the acceleration of the bus? All right. So it looks like in the x direction, it's accelerating at a constant negative velocity. So it's moving towards the left in the x direction, but has a positive y direction. So it's a positive y direction. So we know it's in this quadrant, it's accelerating it that way. So, what is the magnitude of the acceleration of the bus? So, this is basically just doing trigonometry, right? So, literally just. Literally just, all right, creating a little triangle here, and then we're solving for the total acceleration. So the total acceleration would be negative 2.5 would be a triangle with length negative 2.5 and then positive 3. And then we're basically, um, what is it? We're looking for a displacement in the middle. So, how do you do this? This is a really good question. Because if it was negative 3 and 3, it would just be positive, but it's not. So, all right. So, yeah, I don't really know what to do here. I'm kind of confused because starting from rest, the bus is driving away from the bus stop and accelerating at a constant rate. The x and y components of the bus acceleration are shown to the graph. What is the magnitude? So the total magnitude. Hmm. Well, is this just asking to make a triangle? So, like for example, if you have a triangle and it's 3 and then 2.5, are you asking me to solve this and that's the magnitude of it? Because if that's the case, that would just be 3 squared plus 2.5 squared, and that's equal to 15.25, and cubed, that's 3.9. So, if that's what it's asking for, then 3.9 D would be the correct answer. Booyah, figured it out. Wish I could know why. So it's saying draw the two graphs. Choose the graph that correctly complete the following sentence. Graph blank represents the x component of the bus's velocity. So the x velocity in the x direction is negative, so it's increasing in the negative direction. And it starts from, we don't really know where it starts from, but we just know that it's um, constantly getting more negative. So D would be the correct answer of the x component of the bus's velocity. So graph D, yeah, and then graph Y is increasing in the positive direction, so it will be C because C is the only one that has an increasing velocity because A and B are constant velocities. Yep. So C. All right. So yeah, I literally just said So calculate the values of the x and y's velocity. So man, this is weird because it's like, yeah, I mean I get it, but I also don't get it because it's doing like the Pythagorean theorem, which would you think would be used for length, but they're using it in this case for like for velocity. So calculate the values, the x and y components of the bus's velocity of the magnitude. Well, I guess like yeah, yeah, because you're like making a triangle, I guess, but it doesn't really give you an angle. So they're just doing 3 times 5 and then that squared. Okay, yeah, makes sense. I'm tired, bro. Yeah, so displacement, what was that equation that we used earlier? It was like one half velocity multiplied by time, and then they're doing that to solve for like the displacement or whatever. And that was that. What equation was that? That was No, they didn't go over that formula yet. So maybe I need to write it down. Yeah, maybe I need to write these formulas down, man. Yeah, so I'll go ahead and jot these down. I did pretty well in all the questions, though. I'm just like, want to make sure I conceptually understand it. So, when I do the exam, I don't like freeze up or like take a long time, which will come with just me just doing the rest of these practice tests. But should be module 5, which should be all that I need for this midterm. But we'll see. There's been snow, unfortunately, so a lot of the lectures were like canceled, which has been extremely annoying. So we're behind, and we have like another lecture today. That's like our last lecture before the exam. I don't know if this one's supposed to be on the exam. It's about kinematics. It's not supposed to be, but I don't know, man. I don't trust these professors, bro, for real. You probably should just try to learn it anyway and know how to do it. Well, all right, mates. Hope you enjoyed this chat or me suffering trying to do physics. LOL.